Hello dear students and welcome to Diksha Vedantu Foundation channel. Here we are currently discussing class 10th midterm score booster. Here all the chapters are discussed in detail so that you can score the maximum possible marks. We have already completed light reflection and today I am going to discuss entire refraction with question answer. So all the important questions, all the important concepts, everything will be covered in this lecture. Here all the important concepts are taught via questions. So whatever possible questions that can come from each and every concepts that we are going to discuss, and there will be a lot of question answers in this section. So don't miss a single minute. Let's start with the lecture. First of all, let us look into the overview of the chapter. First of all, refraction of light. Now refraction of light is most important part is Snell's law. Snell's law says that sin I by sin R is equal to constant. That constant is given by refractive index, that is denoted by small n, small letter n, and it is basically the velocity of light in medium 1 divided by velocity of light in medium 2. Generally medium 1 is considered either air or vacuum. In that case it becomes C by V. We know that speed of light in vacuum or in air is basically C, which is a constant. Okay, and then we will discuss about lens. Now lenses are basically two types similar to that of mirrors. Convex lens, it is bulged outward, so convex lens is bulged outward, and concave lens is caved inward, right? So this is convex, this is concave. Now image formation, similar to that mirrors, we will also study image formation by concave and convex lenses. Now instead of what we have studied in mirrors, okay, in concave mirrors they can produce real as well as virtual image, but in case of lenses it actually reverses. Now concave lens always produce virtual and diminished image, and convex lens can produce virtual as well as real image based on the distances, right? And the image distance, object distance and focal length are related by 1 by V minus 1 by U equals to 1 by F, and the magnification is given by obviously minus V by U. So this is same as the mirror, this is slightly different, and most of the students get confused between concave and convex lenses and mirrors, because whatever the mirrors are doing, lenses are doing in the opposite order. So but don't worry, okay, I will try to help you at the end of this lecture how you can improve on that. But before that, whatever lectures, whatever videos that we are doing, you can watch them and download the lecture PDF by clicking on the link given in the description. You can go there and you can download the PDF of today's lecture. Now let's continue. First let us look into refraction of light. Okay, light rays changes its direction as it enters in another medium. Now what are the possible cases when the light ray changes its direction? Only for oblique incidence, only for normal incidence, any type of incidence, it does not change its direction. Okay, so light when it's traveling from one medium to another, it changes its direction only for oblique incidence. For any other incidence is that for example, if there is one medium, that is two medium, second medium, okay, light ray is incidenting normally, it will not change its direction, it will go straight. Okay, it will go straight. But if you are considering any oblique incidence, for example, if a light ray incident like this, then it will change its direction based on the obviously refractive index of the second medium. Now let's assume this is air, this is water, then the medium, the light ray will bend towards the normal. Okay, we will discuss that in a while. So this is the way refraction happens. So in case of refraction, the light ray changes its direction only for oblique incidence, not for normal incidence. For normal incidence, it passes straight away. Okay, now let's move on. Now let's look into the Snell's law, very important. If I is the angle of incidence and R is the angle of refraction, then which of the following is correct? Here n is given by refractive index of the second medium. Is I equals to R like reflection? No, this is not correct for refraction. Sin I is equals to sin R, basically same thing. right? I hope you have already familiar with the ratio of triangles, right? Sine, cos, tan, etc. Now n equals to sin I by sin r, or n equals to sin r by sin I. So basically n equals to sin I by sin r. So correct option is option C. This is the Snell's law. Snell's law is basically telling you that sin of angle I and sin of angle R is basically constant, right? And that constant depends upon the pair of media, okay, and that constant is basically called refractive index or Ri and denoted by a symbol n. Okay, this is the basics of Snell's law. Now let's move on, see one more problem on Snell's law. A figure shows a ray of light as it travels from medium A to medium B. Okay, refractive index of the medium B relative to medium A is. So what is this figure is about? So here they have given one. This is the medium number A. Okay, so this is the first medium. Generally, whenever we see an image, our top part is medium 1 and the below part is medium 2. But in this case, they have reversed it. So you have to be careful. Don't start solving problems blindly. Okay, you have to be careful what is given, what is the direction of ray is given. So here the ray is starting from the below and it is going up. So what is the angle of incidence? Angle of incidence is this. We know that we always measure angle from the normal, not on this plane. It is always measured on the angle normal. So this is angle of incidence. Similarly, this is the angle of refraction. Okay. So now we know that from Snell's law, n is equal to sin I by sin r, right? Now let's start solving this. N, we are trying to find the refractive index of medium A with respect to medium, what we are trying to find is refractive index of the medium B with respect to medium A. Very important. Medium B with respect to medium A. So that means we have to calculate sin I by sin r. Second medium with relative to first medium. So sin I by sin r. So what is sin I? So n is basically sin of I is 60 degrees, right? So sin 60 degrees divided by sin r, sin of 45 degrees. So what is sin 60 degree? Tell me the value of sin 60 degrees. Whoever is saying 1 by root 3 or 1 by 2, they are wrong. It is root 3 by 2. Root 3 by 2 is the value of sin 60 degree, right? And sin 45 degree is 1 by root 2, right? So now let's calculate the value. It will be root 3 times root 2. This root 2 will go up and there will be another 2 in the below. Now this will cancel with another root 2. So 2 can be written as 2 is basically root 2 times root 2, right? So one of the root 2 will cancel, so another root 2 will stay. So the correct answer is root 3 divided by root 2. So root 3 divided by root 2, option A is correct, right? Now let's move on. Solve one more problem on Snell's law. A light ray enters from a medium A to medium B as shown in the figure 10.2. Okay, the refractive index of medium B relative to medium A will be. Okay, now light ray is entering from medium A to medium B. Now they have asked you only which medium will have a greater refractive index. Okay, refractive index of medium B with respect to medium A. Now what is the angle of incidence? If you see this, this is the angle of incidence, right? This is the angle of incidence I, this is the angle of refraction R. Now tell me which angle is greater, incident angle is greater or refractive angle is greater. So obviously from this diagram I can tell you that I is obviously greater than R, right? So R is smaller. You can see it clearly from this image. It is almost very close to this line, but after reflection it is bending towards the normal. Bending towards the normal means refractive index of medium B should be greater than that of medium A, right? So suppose this is air. If this medium is air, and we assume that this is air, so air has a refractive index equals to 1. Okay, and refractive index of this medium should be greater than 1. Say water. Okay, for assume simplicity, assume glass. Okay, assume glass has a very good refractive index 1.5. Okay, so 1.5 is the refractive index of this. Now what is the refractive index of this medium with respect to this medium? Refractive index will be 1.5 divided by 1, so it will be 1.5, right? So we have taken one practical example and we have realized that this is always greater than unity. Okay, so it is always greater than unity. So correct answer is option A. Again, option A is correct answer. Less than unity is incorrect. Equal to unity incorrect. Equal to unity would have happened if it was passed without deflection. That means refractive index will be equal to infinity. Obviously 0 is not possible. Now let's move on. Refraction through a glass slab. Now Snell's law is over. Let's move on to refraction through a glass slab. Very important concept. Why does a light ray incident on a rectangular glass slab immersed in any medium emerges parallel to itself? Explain using a diagram. So we know that when we have a glass slab, okay, after incident the light ray passes parallel to the incident ray. Let's look into the first reason first. In the extent of bending of a ray of light at the opposite parallel faces AB, I am going to show the image as well. So if you see that the light ray is coming from here, okay, after emerging out, this ray would have been passing through this and it is actually passing through this. That means this is these two rays are parallel, right? These two rays are parallel. Now why this is happening? Because the way it is getting deviated from this surface AB, the same amount of deviation is happening on ED, opposite direction. So suppose this is air, okay, and this is glass, right? Now when the light ray is entering from air to glass, some deviation is happening, say 30 degrees, okay. Now it is traveling with that deviation in this direction. Now once it is emerging, the deviation is minus 30 degrees. Okay, so that's why the overall deviation is 0. That's why they are parallel. But since it has passed through this media for some time, there is something called, this is a lateral displacement. This is called a lateral displacement. Okay. Sometimes they will ask you what is lateral displacement, or sometimes they will ask you mark lateral displacement. So that's why I have given you as the, however the light ray is shifted sidewards slightly, this is known as lateral displacement. So when light ray emerges out of a glass slab, the emerging ray is parallel to the incident ray, but it is shifted rightward. That shift is known as lateral displacement. Okay, so this is the definition that you have to write if they ask you what is lateral displacement. Now let's move on to another question. Now refractive index. Now let's look into the refractive index in detail. So far we have only looked into refractive index in the perspective of Snell's law. Now let's look into the refractive index from the definition of refractive index. How the refractive index of a medium is related to the speed of light, and obtain an expression for refractive index of a medium with respect to another in terms of speed of light in these two media. Okay, first of all, let's look into the refractive index. The relationship between refractive index of a medium and speed of light is given by refractive index of a medium is basically speed of light in air or vacuum or free space divided by speed of light in that medium. So refractive index is basically C by V. Okay, C is what is C? C is speed of light in air, right, or vacuum or free space. That is 3 times 10 to the power of 8 meter per second, right? We know this is a constant. Speed of light in air, right? We already know that. Now let's move on. Now let us answer the second part. Obtain an expression for refractive index of the medium with respect to the another in terms of speed of light in these two media. Now what is the refractive index of say second medium with respect to first medium? These are the two mediums. Suppose light is traveling from one medium to second medium. Okay, light is traveling like this. Okay, now refractive index of this medium is N1, refractive index of this medium is N2. Now what is N2? Now N2 by N1 is basically defined by refractive index of the medium N2 divided by refractive index of medium N1. Now what is N2? N2 is C by V2, that is speed of light in the medium 2, and N1 is C by V1, right? Or we can write this equals to V1 by V2. So we can write that N12, sorry, not N12, it should be N21. Speed of light in the second medium divided by speed of light in first medium. Sorry, it is correct. This is N12, and N21 is basically speed of light in first medium divided by speed of light in second medium, right? So this way we have found the relationship between speed of light and refractive index. If you leave your answer here, you will get full marks. This is only I have given you another option that if you want to reverse it, instead of N21 you can calculate in 1-2 as well. Okay, that is, even though light is traveling from first medium to second medium, if you use this formula, you can find the refractive index of the first medium with respect to second medium as well. Okay, so that is how we can calculate the refractive index of a medium. Now let's look. Refractive index of diamond with respect to glass is 1.6 and absolute refractive index of glass is 1.5. Find out the absolute refractive index of diamond. What is the meaning of absolute refractive index? Absolute refractive index is basically, suppose we are finding for glass. So absolute refractive index, we already know that this is C by V, G, right? So this is the formula, and also absolute refractive index of diamond is C by Vd. Also what is given is refractive index of diamond with respect to glass is 1.6 and absolute refractive index of glass is 1.5. Generally absolute refractive index is denoted by only one subscript, and absolute refractive index of one medium with respect to another is denoted by two medium. First is the medium for which we are calculating, and second is for with respect to what it is being calculated. Now we already know one formula. NdG is basically refractive index of diamond divided by refractive index of glass. Now that is given as 1.6, right? Now Ng is also given 1.5. So Nd, let me use the other space. We have a lot of free space here, so let me utilize that. So Nd is basically 1.6 times 1.5, right? So we can write this as Nd divided by 1.5, right? So Nd is equals to 1.6 times 1.5. Now how can you calculate that? So 1.6 times 3 by 2. 1.5 can be written as 3 by 2. You are not using any calculator, so 0.8, and 3 8s are 24. There is one decimal, so 2.4. Refractive index also remember that does not have any unit. It's a ratio, so it's a unitless quantity. If they ask you in exam, they give some options and they ask which of the following is a unitless quantity, then you have to remember that refractive index is a unitless quantity. Okay, even though it's a physical quantity, it has a value, but it does not have any units. Now let's move on. You are given water, mustard oil, glycerin, kerosene. In which of these media a ray of light incident obliquely at the same angle would bend the most? Now out of these four media, which one has the maximum refractive index? Light will bend the most for that medium, right? Now from this given list, it is very clear that our kerosene, water, mustard oil, only glycerin has the highest refractive index. So answer is easy to guess. Okay, glycerin is the answer, but you should be able to answer this only when you know the refractive index of the corresponding mediums. Okay, so refractive index of kerosene is 1.44, refractive index of water is 1.33, refractive index of mustard oil is 1.47, and glycerin is 1.473. They are very, very close. If you see, mustard and glycerin are very, very close, but glycerin is slightly denser, optically denser. Now you should remember that optically denser means whoever has higher refractive index. Okay, optically denser means higher refractive index. Now there is one example, kerosene and water. Okay, kerosene is optically denser compared to water. Okay, kerosene is optically denser than water because as you can see, kerosene has 1.44 and water has 1.33. But the density of kerosene is much lesser compared to water. Okay, so even though kerosene is optically denser than water, okay, water is mass density of water is greater than kerosene. But in case of glycerin, glycerin is not only denser in mass density, it is also denser in optical density. Okay, so this is one of the example where mass density is less but optical density is more. Okay, so density, optical, sometimes you might face this term density or mass density, okay, or optical density. Density normally means mass density, optical density means refractive index. That much you have to remember. Now let's move on to the previous day's homework problems. Now we are going to solve all the homework problems that I gave you in yesterday's class, not yesterday's class, in the last class of mine. At what distance from a concave mirror should an object be placed to get an image of the same size as the object? Okay, so at what distance from the concave? So mirror was concave mirror. Okay, and they have said that same size as the object. Same size as the object means where do we get same size? When the object is placed at center of curvature. Okay, so the object should be placed at the center of curvature. Okay, at the center of curvature of the mirror. Okay, or in other some sense they might ask you at R. Okay, at a distance R, at a distance 2f, both are correct. Okay, at a distance R means radius of curvature, that is radius of curvature generally represented by R. 2f is the double of the radius focus, that is also equals to R. So this is also can be possible option. Now let's move on to the next part. Next question, at what distance from a concave mirror should an object be placed to get an inverted and magnified image? Now yesterday's table, if you remember the table, that when the object is placed between focus and center of curvature, okay, when you place this object here, we get an inverted but magnified image. Okay, so inverted and magnified should be between C and F, and erect and magnified should be less than F. Okay, this is another option, another possibility from this chapter. Now the principal focus of the mirror, obviously no. Okay, beyond center of curvature, no. At the center of curvature of the mirror, no. Between the focus and center of curvature of the mirror, so correct option is option D in this case. Now let's move on. Concave mirror produces 3 times magnified enlarged image of an object placed at 10 centimeter in front of it. Where is the image located? Okay, stated laws of reflection of light. I will not answer this question. It is discussed in yesterday's lecture, previous lecture. Now only I will going to solve this numerical question. If you have any question related to this laws of reflection of light, you can mention that in the comment below. I am going to solve this numerical problem. A concave mirror, okay, produces 3 times magnified real image. Okay, so real image means obviously we know that real image means magnification is negative, and we know that V by U. Okay, so object is placed at 10 centimeter. So object is placed at 10 centimeter means what? Minus V by minus 10, right? So object is placed at 10 centimeter means it must be minus 10. Now how many times? 3 times real image. Real image should have a negative sign. We have discussed if the magnification is less than 0, then it's a real image. If the magnification is greater than 0, it's a virtual image, right? Now let's calculate V from this equation, right? From this equation we can calculate V. So V minus 10, that is V by 10. This minus minus cancels, equals to minus 3, or V equals to minus 30. Okay, V we got. Okay, so image is located at minus 30 centimeter, that is on the same side as the object. Okay, so image is located as at minus 30. It is not a big problem, it's not a huge problem. Okay, only thing you have to be careful is about the signs. So V is 30 centimeter on the same side as the object. This is very important. 2 mark question. Okay, 2 mark question, you have to not only mention the 30 centimeter but also which side it is. Okay, you can mention left side also. Okay, or instead of that, if you don't have time, you can mention left side. That is also fine. Generally left side is taken as the side of the object. Okay, so you can mention left side. Now let's move on to the next long answer type question. An object of height 5 centimeter is placed at 15 centimeter in front of a concave mirror. Okay, so 15 centimeter in front of a concave mirror of focal length 10 centimeter. So an object is placed somewhere here. Okay, so U is given 15 centimeter. Okay, and height of the object is given 5 centimeter. Okay, height is given 5 centimeter, U is given 15 centimeter. Okay, focal length is given 10 centimeter. Okay, signs are not given. Okay, signs you have to take. At what distance from the mirror should the screen be placed so that focused image is obtained on it? Now we know that U is always minus. U is always minus for concave mirror. Okay, the focus is somewhere here, so it is on the left hand side, so focus is also minus. Okay, focus is minus, U is minus, right? So what we have to do, you have to use the mirror equation. 1 by V plus 1 by U equals to 1 by F. Okay, or what is 1 by V? We don't know, obviously. What is 1 by U? U is minus 15. Okay, and F is 10, right? Now calculate 1 by V. This will go to the other side, so it will become 1 by 15 plus, okay, it was negative here, but this will become minus 1 by 10. Now solve this. What is the LCM? LCM is 30. Okay, 2 15s are 30 minus 3 10s are 30, so it will become minus 1 by 30. Okay, so V will be minus 30 centimeter. So this is, in this case also V is 30 centimeter, right? And find the nature and the height of the image. So it is obviously V is negative, means real image. Okay, image distance is 30 centimeter. Obviously, since the height of the the object distance is negative, that means it's a real image for mirror. Now what else? We have to also find the height of the image. Height of the image divided by height of the object is basically magnification, that is equals to minus V by U, right? So H dash is minus V by U, or minus 30 divided by minus 10. So it is minus 3. Okay, so H dash is minus 3 times H. Okay, so H dash is minus 3 times, what is the height? Height was given 5 centimeter. So minus 15 centimeter. Okay, what is the significance of this minus? Negative sign signifies that the image is inverted. So don't worry in case of optics if your answer is negative. In optics, especially for mirrors, lenses, etc., negative answer is quite acceptable. Okay, when we move into next chapter or when we are solving electricity, then in that case negative value may not be realistic value, but in case of optics, negative value is quite acceptable. Even if your final answer is negative, don't worry, you have to mention the significance of the negative value. Okay, now this is a very interesting and important question. Study the data given below showing the focal length of 3 concave mirrors ABC and the respective distances of the objects placed in front of the mirror, right? So in which cases the mirror will form diminished, I guess I answered the first question, diminished image of the object, justify your answer. So what is the first part? First part of the question was in which cases the mirror will form a diminished image. So obviously all of them are concave mirrors, so only when the object is beyond the 2f the image will be diminished, right? So beyond 2f is only possible in this case. Okay, so when the object is placed beyond the 2f, so if in this case it is exactly at 2f, in this case it is even less than f. Okay, so now for mirror A, so first answer should be mirror A. Okay, mirror A is the correct answer. I already answered this question. Now let's look into the next question. List 2 properties of image formed in case 2. So what are the properties of the image formed in case number 2? So we know that in case 2 object distance is equals to 2f, right, or equals to r. So the property should be number 1, the size of the image is same as the size of the object. Okay, this is number 1. Number 2, the image is inverted and real. Okay, these are the 2 properties of this image. Okay, we know that when the object is placed exactly at 2f, the image is obviously real and its size is obviously equal to the size of the object. Okay, now what was the last question? What is the nature and the size of the image formed by the mirror C? Draw a ray diagram to justify your answer. Now this ray diagram I have explained and drawn in the previous class. So I am not going to explain the ray diagram part. You can go and check the ray diagram, how to draw a ray diagram for this case. This is a special case, I draw it. So now what is the focal length? Focal length is 30 and the object distance is 20. So we know that the object distance is less than the focal length, so image is virtual, erect and magnified. Right, so that case you have to draw. If you remember, I have drawn that. I am just roughly drawing it. Okay, so this is focal length. Okay, so image will be like this. Okay, I am just roughly drawing it. I am not drawing it properly. Okay, I am doing a cheating. Don't try to do cheating in your exam. Okay, in your exam if you do cheating for this, they will catch you, but for any other case if you do cheating, they may not be able to accept. Okay, right, so this is a way to draw the diagram. Even this diagram is not properly very correct. So what I will do, Okay, this should be the image. Okay, now you remember that this is the diagram I have completed in my previous class. So if you have any doubt, you can go back and check the previous class diagram. Okay, and the image will be virtual, erect and magnified. What all they have asked, that what is the nature? Nature is virtual. Okay, nature is virtual, size is magnified, image formed by the mirror. See, so they have not asked it if it is erect or not, but you can mention that as well to get some extra attention from the teacher. Now if you are still wondering where I can get all the data, all the information that is being done in this lecture, you can go and check the link given in the description below. You can download the lecture PDF from that link. Okay, and everything with annotation will be available in this PDF, so you do not miss out to if you want to score better in your midterm exam. Now let's move on to the next question. A lens forms a virtual, erect and diminished image of an object. Identify the type of this lens. Draw a ray diagram to show the image formation in this case. So basically this is an image is concave lens. Obviously concave lens always forms real and virtual image. Now virtual and diminished image. Now how you can quickly draw a mirror lens? Okay, mirror drawing I have explained. Okay, now how you can draw a lens? Okay, now there are multiple ways to draw a lens. Okay, one thing that you can use is use your angle measuring device to draw the lenses quickly, or you can use compass, no problem, but using compass is difficult. There are some certain shapes are available on your geometry box. Nowadays there are different scales are coming with different shapes. You can use that, or the most important simple thing that you can use is your D. Okay, D available in your geometry box. The D where what you use to measure the angle, right? I don't know what you call. We used to call it D. So if you call it anything else, you can mention that in the comment below. So first thing what you have to do, you have to draw a straight line. Okay, you have to draw a straight line like this. This principal axis, obviously you have to draw it first. There is no exception in case of mirrors, in case of lenses. Principal axis you have to draw first. Okay, then if you are drawing concave lens, take on extreme rightmost extreme point as much as possible, then draw a line like this. Okay, and then touch your D at the center. Okay, or somewhere some distance from the from this point, then you take a line like this. Okay, similarly you reverse your D. So initially your D will be this. Okay, then your D will be like this. Okay, now for exact very accurate result, what you have to do, you have to take this point equally separated so that you can draw it quickly. Now once these lines are done, you can join them to get your concave lens. For convex lens, what you can do, you can draw first this, okay, then reverse your D and draw like this. Use your D to draw the lenses perfectly. You have to practice a little bit to get it exactly perfectly aligned. Okay, but don't worry, you can get it, you can draw it. It's not a very difficult task using your D's if you are drawing any lenses. Okay, now once your lenses are done, so I am here to help you out on all the tricks and tips. Now similar to that of mirrors, okay, convex mirrors, here it is concave lens, right? Now first ray will be always parallel to the principal axis that we are considering. Once the ray is passing through the parallel to the principal axis, you have to draw it backwards to meet it at F1. Okay, and then you have to take another line which is passing through the optical center of the lens, and it will pass undeviated, similar to that you used in case of center of curvature. Remember, in center of curvature it does not deviate, it just goes in that direction and come back in the same direction. In this case we will use the optical center. Any ray passing through the optical center will always pass undeviated. Okay, now remember that for concave lenses, this focal length, this focus is on the left hand side. For convex lens, the focal length is on the right hand side. That is only change. Same as mirrors. Okay, in concave mirrors, the focal length was on the left hand side, right? Same as lens. Okay, in case of concave lens also, the focal length is on the left hand side, but it produces virtual images, virtual and diminished images. Okay, in concave mirrors, if you remember, in concave mirrors, our focal length was on our right hand side, but that side was a virtual side. Now in case of lenses, that side is no longer a virtual side, that side is actually a real side, because it can pass through. In case of mirrors, it is actually reflecting back. Okay, that's why even though everything was same, concave mirrors were actually producing real images, and convex mirrors were actually producing virtual images. Now since the table has turned, now our right hand side has become a real side and left hand side has become a virtual side. So we can say concave mirror will now produce concave lenses will now produce a virtual image, and convex mirror will now produce convex lens will now produce a real image. Okay, so that is the basic difference, why it is happening, why convex mirror is producing virtual image but convex lens is producing real image. Okay, because of the sides. Okay, everything else remains the same. Now if you look into the table, as same as that our convex lens, convex mirror, say everything is same. At infinity, the object is formed at focus. Okay, and behind the lens, okay, behind the lens means on the left hand side, sorry, not behind the lens, on left hand side. Okay, left hand side. Okay, highly diminished, point sized, virtual and erect. Okay, between P and F, not, so this is not behind the lens, this is left hand side. Okay, and similarly here also it is not behind the lens, it is LHS. Okay, I am simply writing in short. So left hand side of the lens, between P and F, you will get a diminished, virtual and erect image. Okay, when the object is located between infinity and not pole, pole of the lens, you can say pole or optical center. Okay, optical center, you can mention optical center as well. Now let's move on. Now let us look into the image formation by a convex lens. A convex lens of focal length 20 cm can produce a magnified virtual image as well as a real image. Is this a correct statement? So a convex lens of focal length given as 20 cm can produce a magnified virtual image as well as magnified real image. Okay, magnified virtual as well as real means this magnified is common. Okay, this is common, x a plus b. So x common, a plus b, magnified virtual as well as magnified real. Okay, is this a correct statement? If yes, where shall the object be placed in each case for the obtaining this image? Let us look into the answer. So answer is, a convex lens can produce a magnified real image when it is placed at a distance between f and 2f. Okay, so magnified image is produced when the object is placed at a distance between f and 2f, and if the distance is less than the focal length, it produces a magnified virtual image. Okay, so when the object is placed between f and 2f, or basically you can write f1 and 2f1, okay, and if the distance is less than the focal length, it produces a magnified virtual image. Thus the statement is correct. So let's look into the actual answer. Magnified virtual image is formed when the object is placed between 0 to 20 cm, that is from the optical center till the focal length, right? And magnified real image will be formed when the object is placed between 20 cm to 40 cm, that is from f to 2f. Okay, in between that range the image will be real but magnified. When the object is placed between 0 to 20 cm, obviously virtual images are always magnified in case of convex lens, similar to that of concave mirror. Okay, we have seen that in concave mirror virtual images are always magnified. Similarly in convex lens virtual images are always magnified, right? Now let's look into the summary of convex lens. Okay, so only difference is in case of lenses, the virtual image is forming on the right hand side, as well as real images are also forming on the right hand side. Okay, I will show you using one example. Okay, so in both cases virtual and real images are on the same side, but in one case you can take the image on a screen, whereas for other cases you have to see from the other side to observe the image. You cannot take that image on the screen. That is the basic difference. Now let's look into one MCQ. At what distance from a convex lens should an object be placed to get an image of the same size of the object on the screen? Obviously same as concave mirror. They have asked you at what distance you will get a object of the same size image as the same size of the object. So obviously it should be at the twice of the focal length of the lens. Okay, the thing is same. Okay, only thing is there is no center of curvature mentioned in this case. So only thing that you have to be careful is it should be 2f. Okay, draw a ray diagram to show the path of the refracted ray in each of the following cases. A ray of light incident on a concave lens parallel to its principal axis and directed towards the principal focus. Okay, so this question I have already explained, I have already solved this. Okay, parallel to principal axis. So we have a concave lens. Okay, and what they have said, parallel to principal axis. So a ray is going parallel to principal axis. I have already said when the ray is parallel to principal axis, suppose this is the focus. So after passing through the lens, it will pass like this, right? This will pass like this, and it is directed towards the principal focus. So principal focus is this for concave mirror. Okay, so it is directed. Suppose a ray is directed towards the principal focus. So after passing through the lens, it will become parallel. Okay, same principles are same as mirrors. Okay, in case of mirrors also, only thing is that was happening in reflection. Now it is happening, everything is happening on refraction. Okay, once it is passing out of the lens, it is appearing to come from the focus, and when it is going through the focus after refraction, it is becoming parallel to the principal axis. Okay, so this is case number 1. This is case number 2. Okay, now the important problem that I am going to solve is this. A 4 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 24 centimeter. So focal length is given 24 centimeter. The distance of the object from the lens is 16 centimeter. Okay, distance of the object from the lens is 16 centimeter. Find the position and size of image formed. So let us now look into the position and size of the image formed. So a 4 centimeter tall object, so height of the object is 4 centimeter, right, placed perpendicular to the principal axis of convex lens. Okay, perpendicular to means like this. This is perpendicular, right, of focal length 24 centimeter. Focal length is given 24 centimeter. Focal length is given 24 centimeter. Okay, the distance of the object from the lens is 16 centimeter. So the distance is 16 centimeter. Okay, find the position and size of the image formed. So what we have to do, you have to find the position and the size of the image formed. So what is the position? We know that 1 by V equals to 1 by V minus 1 by U equals to 1 by F, right? Now what is 1 by V? 1 by V we don't know. 1 by U is given 16 centimeter. Okay, 16 centimeter should be negative. Okay, now focal length for a convex lens is positive, same as that of convex mirror. Okay, In this case, everything is similar to the mirror and lenses, but only when it comes to the properties of images from, type of the images from, they are reversed. Okay, sign, in terms of sign, everything is same. Okay, so the focal length was given 24 centimeter and it should be positive because focal length is on the right hand side. So 1 by V equals to 1 by 24. Now this is becoming positive, so it will go in that side and it will become negative. Now what is happening? 48 is the LCM. So 48 means 2 minus 3. It is minus 1 by 48. So V is basically minus 48 centimeter. So what is the meaning of that? So image is forming on the same side as the object. So if the image is forming on the same side of the object, then obviously we know this is a virtual image, right? So what is happening? So object is here and image is forming somewhere here. Okay, so image is forming on the same side as the object means in case of lenses, this is a virtual image. Left hand side of the lens, so this is a virtual image. So what else they have said? Find the position and size of the image formed. Size of the image also you have to find. What is the size of the image? Size of the image is magnification. Magnification is given by minus V by U. Okay, so minus V minus 48. Okay, V is minus 48 and U is minus 24. In case of lenses, I think the sign is positive. Yes, in case of lenses, V and U are opposite signs, so that's why this is positive. So it will be 2. So image is twice as magnified as the object. So I made a mistake here. Okay, magnification for lenses, it is plus V by U. Okay, not minus V by U. Okay, so negative sign comes automatically. For mirrors, the negative sign should be there. So magnified, it is twice as magnified and it is virtual. Okay, now let's move on to the next problem. Anything else? No, nothing else. Now as we have discussed for two special cases, here we have object any position between F to F or any beyond to F, any cases. Okay, any starting from beyond to F till F, any point. Okay, when the object is placed, you have to consider two rays. One ray is this, it will pass through the focus on this side and this will pass through the center of curvature, optical center of the lens, right? And whenever they intersect, you will get the image there. Okay, this is a special case, this is normal case. Okay, now you have to remember that when you are drawing, there are two special cases. One special case is this, when the object is located at 2F. Okay, what you have to do, suppose first of all you can take any distance as F, does not matter. In this case you don't need to be technically correct like in mirrors. Okay, you have to take some F, say 10 centimeter in this case, 10 centimeter in this case. Okay, what you have to be careful about is don't take any F or 2F. I will suggest don't take any F or 2F at this point. What you have to do, you have to take 2F points. Okay, now draw a 2 centimeter line or 4 centimeter. 4 centimeter I think should be sufficient. Don't take 2 centimeter, 2 centimeter is very small. So use 4 centimeter line, 4 centimeter arrow, upwards arrow. Okay, 4 centimeter upwards arrow you take, and you take another downward arrow of 4 centimeter. Okay, now once you have completed these two arrows, you take one parallel line like this and then you join this. Okay, and then you take this line and then you join this. Okay, now you draw the lens. Based on this you draw the lens. Lens will come last. Okay, you can draw it roughly. Okay, using your D's, compass D's. Don't draw roughly using pencil only. Okay, then they will deduct marks. Okay, you have to be very careful about the geometry of the lens. So use your D's properly to get the lens done. Now you say this is f, this is 2f, okay, fine, right. So this is one way of drawing. Another very important diagram is when the object is, I already shown it to you partially, okay, when the object is less than f distance, okay, when the object, suppose this is object is located very close to the lens, okay, what happens in this case, suppose this is the focal length, okay, so after passing directly, it is passing through the focus and this passing through the, say, optical center, okay. Now they do not intersect anywhere as you go this side, they will only intersect when you go backward, okay, when you go backward they will intersect somewhere, okay, and this is the basically one way of finding the object, okay. Now I have taken the focal length very less, so it is going very far. Now instead of that, what I will do, I will take the focal length little bit far, okay. So in that case they will easily merge closer, okay. So this is that some few tricks you will learn with practice, okay, this is the few tricks you will learn with the practice. Now this is the virtual image, okay, this is the virtual image because you cannot see this image on a real image. For real images the rays has to be intersecting each other, but in this case as you can see rays are not intersecting but they are appearing. Appearing means when you are using dotted lines, that means the rays are appearing to come from that point. Now what is the usage of this thing? You have seen magnifying glasses, right? When you read something or Sherlock Holmes movies or some detective stories, they always show some magnifying glass to detect the crime, right? So this is a magnifying glass. Magnifying glass is nothing but a convex lens which is used to magnify small objects, okay. Based on the focal length of the lens, it can magnify small to very small objects, okay. Now let's move on to the formula of lens, okay. This is the formula of lens. This formula is valid for all situations, for all spherical mirrors, for all positions of the object, okay. I have already used this equation once, okay. You must use the new Cartesian sign convention, as I said, that while substituting the numerical values for UVF, okay, in the mirror formula for solving problems, okay. Now let's move on to the magnification. An object is kept on a distance u in front of a spherical lens. The image is formed, so it is plus v by u, not minus v by u, okay. What is the magnification of the image? Magnification of the image is v by u. Now a concave lens has a focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? Also find the magnification produced by the lens. So what is this? The focal length of concave lens is given. Focal length of the concave lens. Focal length of concave lens. I think I made one mistake in previous problem. Let me go back, check. Yes, in this problem I have considered the focal length of, yes, it's correct. Now focal length of a concave lens, okay, is negative because concave lens focal length is on the left hand side, okay. Anything on the left hand side is negative. So focal length of a concave lens is negative, okay, and the length is minus 15 centimeter, okay. At what distance should the object from the lens be placed so that it forms an image 10 centimeter from the lens? Now object distance is given, image distance is given 10 centimeter. Now we know that for virtual images, objects and images are on the same side, especially for lenses, okay. So also find the magnification produced by the lens. So magnification we have to calculate u, okay. So let us first calculate u. We know that 1 by v minus 1 by u equals to 1 by f, right. So what is v? V is minus 1 by 10 minus 1 by u equals to 1 by minus 15, okay. Now this will go into the other side, or what we can do, we can take the negative common. All three terms are negative. If you see, we will take the negative common and it will become 1 by 10 plus 1 by u equals to 1 by 15, right. Now let us calculate 1 by u. So 1 by u is basically equals to 1 by 15 minus 1 by 10. Now what is the LCM? LCM is 30, 15 is 2, this is 3, so this will be minus 1 by 30. So U should be minus 30 centimeter. So object should be placed at a distance 30 centimeter on the left hand side, obviously. Now what is the magnification? Magnification is V by U. So V is minus 10, U is minus 30, so it is 1 by 3, that is 0.33. Okay, so you can write 0.33 or you can keep it 1 by 3, everything is fine. So magnification produced is 1/3. Okay, and the image object should be placed 30 centimeter from the lens. Okay, very important concept is power of a lens. Okay, what is the power of a lens? Suppose for example I am wearing spectacles. Okay, you go visit a doctor and they will say your power is 2. Okay, your power is minus 2, your power is plus 2, or your power is minus 5. So based on what they give you the power, let us understand that how power and focal length of a lens is related. You are provided two lenses of focal length 20 centimeter and 40 centimeter respectively. Which lens will you use to obtain more convergent light? So what is the basic relationship between power and focal length? Power of a lens is basically 1 by f. Okay, minus 1 by f. Okay, minus 1 by f is the power of a lens is basically P equals to 1 by f, where f is in meters. If f is expressed in meters, then power of a lens is given by 1 by f. Okay, now how power of a lens is related? So it is the relationship between power and focal length. If the focal length is in centimeter, then power can be written as 100 by f. You should remember this. Now what they have asked you is that when f is in centimeter, in this case f is in centimeter. Okay, now you are provided with two lenses of focal length 20 centimeter and 40 centimeter. Okay, which lens you will use to obtain more convergent light? More convergent light means whoever has higher power, they will converge the light more. Okay, so for example, suppose we have two lenses. Okay, and parallel rays are falling on this, and if it has a more power, that means it will converge the rays more. Okay, and close to the lens. For another example, if we have a less power, it will convert the rays little bit farther. Okay, so let's see which of the lens will be used to convert the rays more. So power P1 or P20 is basically 100 divided by 20. So it will be, power should be 5 and its unit is diopter. Okay, or D. Okay, diopter or D is the unit of power. Okay, now P40, 100 divided by 40. So it is 2.5 diopter. Both of them are positive. Okay, so both of them are converging the rays. If the power is negative, they are diverging the rays. If power is negative, positive, they are converging the rays. Now both of them are positive. So which one will be more convergent? Okay, whoever has the highest power, right? Who has highest power between these two lenses? Plus 5. So we will use 20 centimeter lens to converge to get more convergent light, because it has a higher power. Okay, you have to mention the comments or mention the reason behind your answer, why you are answering that. You are answering part 2 and not the part 1. Okay, now let's move into the homework of today's lecture. So homework, first problem is this. You can take a screenshot, or I will give you one more way to get this question. Okay, you can take a screenshot, you can solve the question and mention the answer in the comment below. Homework number 2. This is also another question, very important question. You can take a screenshot and answer the question in the comment. I will be coming up with the solution in our next lecture. Okay, whenever there is a next physics lecture, I will be answering all these questions. So don't worry if you are not able to answer them. This is also very important questions, short answer type 1 and short answer type 2. Every question is very important. Okay, take a screenshot, answer the question, solve this numerical and mention this answer in the comment below. Same is this. Answer the question. Okay, if it is a numerical, it's a numerical. Answer the solution in the comment below. Okay, now this is another long answer type question. Very important question. Check the question, try to solve it, mention the answer in the comment below. Now, if you are currently studying in class 10th and if you are wondering what you have to do after your class 10th is over, what should you focus for? Should you focus for medical studies in future or you should focus for engineering studies in future? Then worry not, Diksha is bringing you Diksha Scholastic Aptitude Test or DSAT. Okay, here you have to attend a 1 hour lecture. After the lecture there will be an aptitude test. Once you have cleared the aptitude test, okay, there will be a one-on-one counseling. There will be a counselor available absolutely free of cost. You can attend that counseling. Once the counseling is over, based on DSAT score, you can get up to 90% scholarship if you take admission in one of the Diksha colleges, Diksha PU colleges. Okay, if you take the admission in your class 11th, you will get up to 90% scholarships. Okay, now for that what you have to do, you have to fill up this form. Link is given in the description and our representatives will contact you. So what are you waiting for? Go and register for Diksha Scholastic Aptitude Test today only. Wait, now if you are thinking where I can get all the questions, all the lecture notes, don't worry, the link is given in the description. You can go and download the lecture PDF available in our website. From there you can download all the available PDFs. So don't miss out on anything, and if you think this lecture is helping you, don't forget to share it with your friends and subscribe to the channel. Thank you.